Okay, welcome to this video on running the NICU B starter code. So we're going to be launching Domino here, and I've already forked the NICU B Session 4 NICU B project from the projects that I'm a collaborator on. It's here. So I've already forked it. It's here in my projects now. I'm going to click on this, and I'm going to go to the overview. Here's the assignment sheet for this class, and we're going to go to Files, and then we're going to click on NICU B1. This is the first set of starter code. There's also starter code NICU B2. You'll want to run that as well. This video will go over the first batch of starter code lines. Okay, so here we are. We've already forked the project, so in our FLAPS acronym, let me enlarge this here. In our FLAPS acronym for working in Domino, we've already forked the project. Now we're going to launch our notebook, then we'll start playing around with the notebook, and when we're done, we're going to stop at commit. Okay, so here we are. This is the Jupyter Notebook, or a view of it. We're going to go ahead and launch the notebook. So our AWS machine is queued, it's scheduled, preparing, build, pulling, running. It's just about to, so now we've got access to an AWS machine where we can run this code. So we're going to start at the top, we're going to run the first line, we're going to load up the forecast package. So now we've got access to all the functions inside there. We're going to read in the US births data set. We're going to create a time series out of live births, and then we're going to go ahead and plot those. Let's just add a cell here real quick where, again, as usual, good practice is to go ahead and take a look at the head and tail of the births data, just so we can get a sense for what's here. And we've got really just two columns, so it's straightforward: year, month, and then we've got the number of live births in the months in the US, so we've got that for 66 months. So that's what we've got running here. When we plot a time series, it automatically gives us on this axis the years. Because we've told it to start here, this little C is a collection of, or a combination of, putting 2007, the year, together with the first month. So we're starting in January of 2007, and our frequency is 12. So it knows that it's monthly data in each of the periods. This is the period, this is the first season in the overall period, and then there's going to be 12 of these seasons inside one full period. Okay, so now we're rolling on. We're going to fit the ETS model to the births time series, and we're going to call that births ETS. This is without any kind of model specified, so this will search through all 30 models and find our very best one. Our very best one, interestingly, is AAA, and again, each of these three letters, the first letter goes with the E, the second letter goes with the T, and the third letter goes with the S. And the E is the error, the T is the trend, and the S is the seasonality. So we've got additive error, additive trend, and additive seasonality. And here are our smoothing parameters. We've got global trend and we've got global seasonality. So the model that we're fitting is over here. We take our level, we add to it some number, k, going k steps ahead, the slope, and then we add some seasonal pattern that looks back however many periods in our seasons in our period. So we've got 12 seasons, so this capital M is a 12. So when we want to go out to a January in the future, we look back to the previous January and pull that seasonal trend, and that's how we make our forecast going forward. So we've basically got our additive model plus some additional term that deals with the seasonality. And then, like in our additive model where our level was being updated by putting some weight on the most recent change in the time series, Similarly with the trend, putting some weight on the most recent change in the level of the time series. With these smoothing parameters, we've also got a gamma parameter now that shows up over here in our readout, our alpha, beta, gamma in the exponential smoothing model. We've got an ability to put some amount of weight on the most recent change in the time series, with the rest of the weight on what the seasonal adjustment was in the previous same month when we're sitting there at time t. So we're back here, and we're seeing that there's no weight that's being put on recent changes for updating our view of the trend and the seasonality components, but there is some weight that's being put on recent changes in the recent level amounts when updating our view of the level. So what does this say? We started at 365,000 births in a month. We've got a little bit of a decline in terms of the trend, and then we've got these seasonal factors as we make adjustments for which month we're in. So how does this work? These seasonal components are in reverse chronological order. So we're going from, in this list, a December to a November, and then so on to the very end of this list of seasonal factors to a January. So just quickly scanning through this list, our lowest month is our February. This is going to be 29,000 births below our level plus trend, and our highest month is going to be, let's see, what is that? So this is December, November, October, September, August. So August is our highest month here at 23,000 births above a level plus some number of periods out into the future, our trend, which is a monthly trend, a slight decline in births as we're going forward. So what we'll do is we'll go ahead and just take a look at the list out this way. So we've got this vector. That might be an easier way to see all of this, and we can understand how these factors, the level and the trend, got updated as we sweep through the whole time series. So that's what this is a list of. The same factors, but after we've experienced all of the data points, all of the 66 months in this time series here, how were these factors updated? So back in this model, we've got these updating equations, these three equations, and as we roll through each of the points in the time series, we get new views on what the level, trend, and seasonality are. So we haven't changed much on the B, right? Because the beta was so small, that's 0.0001, and the gamma is also so small, so these seasonal factors are not changing much. And to match these up, this is 1 period ago given the end of the time series, this is 2 periods ago given the end of the time series, and this is back to 12 periods ago given the end of the time series. Because we're ending in June, these don't quite match up. This was beginning in January, so 1 period ago was this, so that went with the December. This ended in June, so what is this, 6 periods ago, that's this one, that's a December as well. So that's how you match these up. Okay, so now what we're going to do is look at a bar plot of these, which is a really nice look. We had to do a little bit of work to give ourselves some labels, and then we had to make our bar plot of the states, the seasonal components. That's these components starting S1 through S12 at the very end after we've updated fully on the data that we have. And we've just ordered them so that we've got, let's see, January through January through May, that's the 7 through 3, and then the 14 through 8, that gives us the June through December in the right order. Not going to spend too much time on how we map those.